Hello. So we are on page 8 of the Unit 8 packet. And today we're going to talk about this idea called absolute value, which is related to an idea we're more familiar with called distance. Okay. So as we go through this lesson, again, we're going to keep in mind, like, what does absolute value mean? We'll get to that later. And also, what does distance mean? So we're going to take a look at a situation here with hot air balloons to help us kind of think about distance. It says several hot air balloons were flying at the same height. The dashed line below represents their starting point. So there'd be this line right here. Which two balloons moved the same distance but in opposite directions? So we're going to think about this situation here. You might already know or notice what two balloons moved the same distance in opposite directions. I'm going to kind of walk you through this activity here, which will help us understand what does distance really mean. First question is, what does plus or positive 8 mean in the diagram? Positive 8. So right here, this dotted line or this dashed line represents the starting point. So where all of these hot air balloons started on this dotted line. What does positive 8 mean? Well, it looks like positive 8 means that's balloon A. It's balloon A. So positive 8 means 8 feet above, that's the key word there, the starting or the starting point. Starting line. So positive 8 would mean 8 feet above the starting line. Well, what does negative 15 mean? Well, looks like that's hot air balloon E. And that means E, negative 15, means 15 feet, keyword would be below the starting line. So again, the keywords here help us kind of understand where are these hot air balloons compared to the starting line. The ones that are negative seem to be below it. The ones that are positive are above it. So now we're going to use a little table here to help us organize our thinking and to think about distance again. So in this column here where it says balloon, I'm just going to write down the names of the 5 balloons. There was A, B, C, D, and E. And then in the next column, we'll write the integer that goes along with each hot air balloon. So A would be positive 8. B is negative 10. C is 0. D is positive 10. And E is negative 15. All right, the next column is direction. And the direction we can see from positive being positive or negative. So if it's positive, that would be above the starting line. Negative 10 or negative would be below. Well, C is 0. So what direction would that be? That wouldn't really be above or below. That would be at the starting point or the starting line. So you can see here, if that's positive 10, negative 10, positive 8, right here would be 0. So if the balloon's on that line, C, it didn't really move anywhere, or if it did move, it just came right back down to the starting line. Poor balloon C. Unless that was the task. Maybe that was the task, is do your best to stay on the starting line. So D is positive 10, that would be above. E is negative 15, which would be below. Now the last column is probably the most important one. Distance. Now, distance is different than position. The positive 8 is more like its position. It's above the starting point. Distance moved means how far from the starting point did it move. Now, there's a key thing a key phrase that we should remember here that's actually been on the front door of my classroom this whole year, actually twice. There's 2 different signs that say this. When you come in next time for math, make sure to check it out. This phrase, and I want you to jot it down here, distance is always positive. So let's say that you're backing up in a car. You're still traveling a positive distance if you're backing up down the driveway. If you're walking backwards, even though you're walking backwards, you're still traveling a positive distance. Okay? So if I walk forward 5 feet, the distance I've traveled is 5 feet. If I walk backwards then 5 feet, the distance I've traveled is still 5 feet. Distance is always positive, no matter what. Unless if it's 0. I guess 0, if you don't travel at all, then that's neither positive or negative. So let's check out this column here. Distance moved, A. A is above the starting line. How far is it from the starting line? It's 8 feet. So that's positive. So this one's key. Look at B. B is 10 feet below, which would be negative 10. But the question is, how far is it from the starting line? It's 10 feet. So it wouldn't be negative 10 feet. It's just 10 feet. That's how far it is from the starting line. C, well, C didn't move at all. So the distance moved for C would be 0 feet. D, how far did it move from the starting line? 10 feet. It's above it's 10 feet above, but how far did it move? It moved 10 feet. And sort of the same thing with E. E is 15 feet below, but how far did it move? It is 15 feet from the starting point. So these distances are positive. These distances are positive no matter what, except for 0. So let's check out these questions. It says, which 2 balloons moved the same distance but in opposite directions? Which is kind of the question we were trying to figure out right at the start. So which 2 balloons moved the same distance but in opposite directions? If you look at the distance column, there were 2 that moved 10 feet. One moved above 10, one moved below, but they both moved 10 feet. So that means it would be balloon B and D. So we can say B and D both moved 10 feet. All right. So these 2, I like these 2 questions a lot, actually. It says, which balloon is farthest away from the starting point? So if you look at the diagram, you look at the distances here too. Which one is moved the farthest away from the starting point? It would be the one that went 15 feet, which would be balloon E. Which balloon is farthest away? So we'd say E is farthest away. Next question, which balloon is farthest above the starting point? So even though it's still the word farthest, there's this word above, which is different than how far away is it. How far above is it is talking about its position. How far away is talking about distance. So there's only 2 balloons above the starting point, A and D. Which one's the farthest above it? It would be D. D is 10 feet above, A is only 8. So D is farthest above. Keyword being above. And it says, how come answers to questions 2 and 3 are different? Well, the reason is because this idea of farthest away is about distance. It doesn't matter if it's above or below. It's just of the ones that are above or below, which one's the farthest away. And farthest above is looking at, again, what I said before, is about like its position. Where is it above the line? We're only looking at the ones above the line. If I had to ask what's the farthest below, it would also be E, because E is 15 feet below. But those 2 words make a big difference there in that question. Distance is always positive. Let's keep that in mind. Distance is always positive. So we're going to look at another sort of example like this, and we're going to have to use some clues to help us figure out the numbers here. If you want to try some of this on your own, go for it, but there's some tricky parts here, so let's try this out. First question is, what does 0 represent in this situation? Well, you can see there's a 0 here. I labeled that myself. It looks like you got a guy or a gal in here swimming. It looks like 0 would be like sea level, I would think. So 0 would just be kind of sea level here. All right. Let's use some clues here to figure out. Well, actually, you know what? Let's fill up the chart with what we have. We do have information about the bird. The bird integer is positive 25. So what would be the direction? That positive would mean above, like above sea level. How far is it from sea level? What is the distance? It's 25 feet from sea level. Excuse me. Now we actually can fill out some information on the swimmer. There's the swimmer. The swimmer is at sea level. So what integer would we use for the swimmer? The swimmer would just be 0. What would the direction be? Well, it's just at. It's not above or below. Well, it's kind of both actually, but he's at sea level, or she. And the distance from sea level would be 0 feet. That person hasn't traveled above or below, really. They're still at sea level. All right, let's use the clues to figure out the other values here. The hang glider is 5 times above the surface. Should be 5 times more above the surface than the bird. Okay, well, here's the bird, 25. The hang glider is 5 times more above the surface than the bird. So it would be 5 times 25. That's like 5 quarters. 5 quarters is $1.25, so it must be 125 feet. All right. Hang glider, 125. The direction's still above. Distance, 125 feet. Booyah. All right, let's talk about the whale. The whale is 3 times as far below the surface as the bird is above the surface. Well, the bird's 25 feet above. The whale is 3 times as far below as the bird is above. So 3 times would be 25 times 3, which would be 75. But since the whale is below sea level, we would use negative 75 for the integer to show it's below. All right, so you got the whale, negative 75 feet below. What would be the direction? Because it's negative, it would be below. And distance from sea level. So the whale, it's below 75 feet below sea level. How far is it from sea level? That's going to be a positive number, 75, because distance is always positive. All right, and then the fish. Let's see what the fish is 3/5 of the way below the surface as the whale is below the surface. 3/5. So I'm going to do a little bar diagram here. I'm going to do fifths. 1, 2, 3, 4. So there's 1, 2, 3, 4. There's fifths. Now, it's only 3/5. So what we do is you kind of take the whale, which is 75, divide it by 5, which would be 15 in each. 15 in each. Okay. Now it's only 3/5. This is 5/5. That's 4/5, 3/5. 15 times 3, it's going to be 45 feet. Well, that's negative, though, of course, because it's below. Negative 45 feet. Okie dokes. Fish is negative 45. What direction would it be? It's going to be below because it's negative. Now, how far is the fish from sea level? Even though its position is below sea level, negative 45, the distance is going to just be 45 feet because distance, always positive. Let's check out these questions here. Which object is farthest from sea level? Farthest, so look at distance. Farthest from sea level would be the hang glider. Hang glider. How much farther below sea level would the fish have to travel to be the same distance from sea level as the bird? So we're looking at the bird and the fish. Well, who's farther from sea level? The fish is. So what this question is asking is, how far will the fish have to go to be the same distance from sea level as the bird? So if for the fish to be negative 25 feet below sea level, it would have to go up 20. So if the fish goes up 20 feet, it will be negative 25 feet, or negative 25 feet below, 25 feet below sea level, which will be the same distance from sea level as the bird. This is a tricky question here. But the fish would have to go up 20 feet to be the same distance from sea level as the bird. All right, which integer would you use to represent a crab that is 10 feet below sea level? Here's the key word, below. So what integer would you use? That'd be negative 10. Now, if it asks for distance would just be 10 feet from sea level, but this is asking for the integer. So you would use a positive or negative. Well, what integer would you use to represent a bee that is 2 feet above? I don't know how many bees make it out to the ocean, but that bee, you'd show it as positive 2 feet. Again, that's talking about position because it's above. All right. It's also asking to represent. So let's talk about distance at all, which is why that can be negative. This one. All right, we'll do one more thing here. We'll wrap it up. Okay. Now, what this question's asking is it's asking us to think about distance. And hopefully at this point, you know the distance is always positive, unless it's 0. That's a V. It's hard to write in this. There you go. All right, it says use the number line to determine the distance between each integer and 0. Negative 2. Well, let's put negative 2 on that number line. How far is negative 2 from 0? Well, here's 0. This is talking about distance. 1, let's kind of show that. 1, 2. Negative 2 is 2 away from 0. That's the distance. That's the distance. Positive 3. Well, here's positive 3. How far is positive 3 from 0? 1, 2, 3. So here's 0. It's 3 away. 3 units, I guess you'd say. 3 units. 2 units. 3 units. So I guess if I were to ask you which point is farther from 0, it would be 3. How much farther is 3 away from 0 than negative 2? Well, it's 1 farther away. 1 more away. 1 unit farther, you might say. Okie dokie. All right, last thing we're going to do is this little chart here. Actually, you know what? Before we get to the chart, I'm going to show you something. So before I mentioned absolute value. Absolute value. And what absolute value is, it's the distance of a number to 0, the distance to 0. And I'll show you the symbol of it. We're going to talk more about this tomorrow or the next time. But to show absolute value, you do this. You put 2 longer vertical line segments, and then in between them you put the number. That means absolute value of negative 2. And what that's really saying is, how far is negative 2 from 0? That's what that's asking. How far is negative 2 from 0? That's what those little lines mean, absolute value. So the answer for this would be 2, because that negative 2 is 2 away from 0. And then for 3, absolute value of 3 this means how far is 3 from 0? That's going to be 3. We'll get into that more next time. All right, here, this chart here, we're going to fill out kind of quick. Okay, it's kind of an easier chart. So it's giving us an integer. It's asking how far is that integer? How far is it between that integer and 0? Well, what's the distance between 4 and 0? It's 4. What is the opposite of 4? The opposite of 4 is negative 4. And then it's asking, well, how far is negative 4 from 0? Well, negative 4 is 4 away from 0. All right, let's try this one. 7. What's the distance between 7 and 0? The distance is 7. What's the opposite of 7? Negative 7. How far is negative 7 from 0? Well, it's also 7. Negative 11. How far is negative 11 to 0? Well, distance is always positive. The distance would be 11. What's the opposite of negative 11? The opposite is 11. What's the distance between 11 and 0? Look at that. It's 11. Negative 13. What's the distance between negative 13 and 0? Well, it's 13. What's the opposite of negative 13? 13. How far is 13 to 0? 13. 19. The distance between 19 and 0 is 19. What's the opposite of 19? Negative 19. Well, how far is negative 19 from 0? It's 19. Last one. Negative 21. How far is negative 21 to 0? It's 21 away. What's the opposite of negative 21? It's also 21. Well, what's the distance of 21 to 0? 21. The key thing is this. Look at these distances. They're the same. They're all positive. I didn't mean to go over that one. So what this shows is that any integer and its opposite are the same distance to 0. Any integer and its opposite, they're the opposites. They're the same distance to 0. So it says, what can you conclude about the distance from 0 for both an integer and its opposite? We'd say they are the same distance from 0. An integer and its opposite are the same distance from 0. So we're going to talk more about absolute value. Can't wait next time. If you have any questions about this, let me know. If not, have a great day, and I'll see you soon. Bye-bye.